So this is our final lesson in Unit 5, or I think we're calling it the Rational Expressions and Equations unit. And it's an application of solving rational equations, which was the previous lesson. Now, all of our applications for regular Algebra 2 are going to be what we call combined work problems, which basically you're going to be told some clues about how long it takes a person to complete a job by themselves versus, what would happen if they worked with a partner. And it's not as simple as just cutting the job in half, because if someone's working at a more efficient rate, they're going to do more work, even though they are going to work the same amount of time. So it's a little confusing, but we're going to set it up in terms of a chart. And for our work problems, it's partner work. So we have Shanice and Mary. And then we're going to set up this chart for all of these problems. And usually the first thing a kid asks after we do the first one is like, do I have to set up the chart? And I would like you to. I think it helps me, it helps you, it helps me grade what you've done, and it helps me point out any misconceptions you have. So the rate that they're referring to in this first column is the individual working rate. So basically, how long does it take this person to do the job by themselves? So for Shanice, it says she can tar the roof, poor girl, it's a horrible job, in 15 hours. So the way we write her rate is she can complete one job in 15 hours. So that's how we're going to write rates today. Mary can do that same job. It takes her 10 hours. So she can do one job in 10 hours. Now the time is referring to time it takes them to work together. And they don't actually tell me that. So that's going to be my variable, and because they're working together, they're going to start and complete the job at the same time. That means they both are going to work X number of hours. And then for the part of the job, the way we're going to fill that part out is it's the working rate times, working rate of the person times the time that it takes them to work together. So basically it's an equation that says this box times this box equals this box. So for us, 1/15 times x, if you think about that, 1/15 times x, nothing cross cancels, of course, you end up with x over 15, and that's how I'd like you to write that right here, x over 15. And then for Mary, her part of job that she's going to complete is x over 10. And this is just the chart. This is just helping us set up our equation. Now we're finally ready to set up the equation. If I take the work that Shanice completes and I add it to the work that Mary completes, they're going to have the job completed by the end of this time. So Shanice's part plus Mary's part equals one completed job. That's the equation that we're trying to shoot for. So we're going to solve this using our skills from the previous lesson. I'm looking for an LCM that will multiply and knock out a 15 and a 10. If you want to find the smallest common multiple, you'd go with a 30. But sometimes kids just multiply these numbers together and put like 150 down. That's fine. You can do that. I'm going to go smaller numbers though because I don't have a calculator right now. So if I distribute, and really crucial guys, don't forget to multiply this 1 by a 30 as well. So 30 times x over 15, the 30 over 15 will reduce to a 2x. 30 times x over 10 will reduce to a 3x. And don't forget, that's not a 1 anymore, it's a 30. So 5x equals 30, and x equals 6 hours. And the question was, how long will it take them to work when they work together? And that's what x is their together working time. So I think we're done, 6 hours. So that's not too bad, right? And when it's a question like that, where you have each individual's working time and rate, then that's how they're always going to be set up. So these problems are a little lame because they're computer generated, so I apologize. Elisa and Brenda. Eliza? Brenda. So bad with name pronunciation. Alright, let's talk about Eliza and what she can do. She can harvest the field in 10 hours. These are horrible jobs. Alright, so her rate is one job completed in 10 hours. That's her individual rate. Brenda can do that same job. It takes her 9 hours. So her rate is one job in 9 hours. Now they're going to work together for some mystery amount of time, so we'll call that x. And then if we were to multiply each person's rate times the time that they work together, we're going to figure out how much of the job each girl completed. So for Eliza, 1/10 times x is x over 10. I like to write it that way. And then 1/9 times x is x over 9. And then we're going to take each person's contribution to the job. We're going to add them up. So x over 10 plus x over 9. And at the end of this problem, when both girls complete their job parts, we're going to have one job completed. So again, I'm shooting for the least common multiple. I think it's 90 actually on that one, because 9 is kind of a stickler of a number. It doesn't have a lot going on with it. So if you multiply everything here by a 90, this new equation 90 over 10 becomes a 9x. This becomes a 10x when you reduce it. And then don't forget the 1, it's a 90 now. That's the most common mistake setting these up, is the child who doesn't multiply the 1. Or knows to do it and just forgets for some reason. Alright, so 19x equals 90. Alright, this is not going to come out pretty. So I'm going to have to go find a calculator. Whoops, what am I doing? 19. So 90 divided by 19, let's see. That works. 4.7. Alright, so the girls are going to work for 4.7 hours when they work together. And poor Brenda's going to do a little more work than Eliza, Lisa, but that's okay. Partners and all that. Daniel and Jennifer. Alright, so very similar question. This will be the last one we do on this front side of the notes, and then I'll show you on the back side of the notes how they can kind of change up the problem a bit. So Daniel can pick 40 bushels of apples. Now that's the job, that's not his time. But it takes him 13 hours. That's his rate. So one job in 13 hours. And then Jennifer can do that same job in 9 hours. So one job in 9 hours. They're going to work together for some mystery amount of time. And then we're going to multiply these together. And multiply those together. So x over 13 is how I'm going to write that fraction. And x over 9 is how I'm going to write that fraction. And then the equation that we set up is Daniel's part plus Jennifer's part. It's going to equal one job. So x over 13 plus x over 9 equals 1. Oh boy. I'm just going to multiply 13 times 9 together to use a common multiple. I think it is the least common multiple as well. But I don't know, and I really don't care because it's an equation and it's all going to reduce. Alright, so 117 divided by 13 is 9x. 117 divided by 9 is 13x. And then equals 117. Some kids who don't have calculators, or just don't want to use their calculator or don't want to think real hard, they like using just these two numbers multiplied together regardless of whether it's the least common multiple or not, because they know basically like this numerator is just going to switch to that number and this numerator is going to switch to that number because of cancellation. It does often produce really large numbers that you're working with, so you're going to have to get a calculator at some point. Alright, so we have 22x equals 117, and then one more step, and this time we need a calculator. So, let's see here, 117 divided by 22. These children are working together for 5.3 hours. That's how long it'll take them when they work together. Teamwork makes the dream work and all that. Alright, we're going to move on to the back of the notes now. We're going to change up the problem a little bit. So we have Shana and Katherine. They have worked together on this job. So we already actually know some information that we didn't know on the previous problems. So Shana, if she was working alone, this was her alone, her independent working time, it takes her 15 hours. So that's Shana's rate, 1 over 15. But then the next clue they give me is that when the girls work together, it took them 6.67 hours to work together. So that's their together working time. This is unusual. They actually told me that number, which on the previous problems we didn't know it. Come on, then. 6.67. And again, they're working together, which means they work for the same amount of time. And this is the question. How long does it take Katherine to do the job? So I'm wondering what Katherine's rate is. So she's going to finish it in a mystery number of hours. So the way I'd write her rate is I would say one job in a mystery amount of hours. So the equation that follows is the same setup. It's rate times time for both girls. And I'm not going to bother making this pretty. I'm just going to say 6.67 over 15 and leave it like that. And then 6.67 over x. And this is how we're going to set up the equation. So Shauna's part plus Katherine's part equals one job completed. completed, and that's what we're going to solve. So, parentheses around the entire equation, and this is more reminiscent of the last lesson where we had variables in our denominator, so 15x would be the common multiple we're going to use here. So when you multiply 15x to every fraction, including the 1, that first fraction, the 15s would cancel, but the x remains, so you still have 6.67x. And then in this last fraction, the x's cancel, so you have, I'm going to type 15 times 6.67, and I get 100.05. And then don't forget that 1 is still being multiplied by the 15x. And now we have a more algebraic looking thing to solve. It's not as simple as the previous questions, of course. So, I'm sure you noticed that the 6.67, not a pretty number, right? And they probably rounded it off. It was probably like literally 6 2/3, and they just ended up rounding. So we're going to get kind of a weird looking answer and just understand that there's some truncation happening here. So 15 minus 6.67 gives me 8.33x. So when you divide by 8.33, you're going to get a number that's really close to a whole number, I think. Oops, except I didn't. Can't type. Try that again. 5. There we go. So on the calculator, it comes out to like 12.01 hours, which that's a great answer, but probably the true answer is 12 hours exactly. They just had some truncation in their math. All right. So same chart, a little different setup. We have Basra. That's a new one. And then we have James. So a Basra can do the job, whatever it is, installing a deck in 10 hours. So that is a Basra's rate of working on one job in 10 hours. James, we have no idea what his rate is, so that's the question. So we're going to set it up as 1 over x. When they work together, their together time here, it takes them 6 hours. So just like before, we multiply each person's rate times their time and figure out how much of the job they're going to complete. So 6 over 10, you can leave it as 6 over 10. You can reduce it to 3 over 5, I don't care. And this is 6 over x. And then just like before, adding up each person's part of the job is going to get us one job completed at the end of this question. So 6 over 10 plus 6 over x equals one job. Common multiple for this rational equation would be a 10x. And let's see what happens when we multiply that 10x into the equation. So first fraction, the 10's cancel and you get a 6x when you reduce. Next fraction, the x's cancel and you get a 60. And don't forget that last one is now a 10x. This comes out pretty nice, right? Subtracting 6x from both sides. 60 equals 4x. And then, what does that come out to? 15, doesn't it? Nice. So, James, if doing the job alone, it's going to take him 15 hours. Good thing he has that partner. Alright, we'll do one more and then we'll call it a day. Eliza, she's back. She's with Ming this time. And they are oiling lanes in a bowling alley. Okay. There's some weird jobs, computer. Alright, we have Eliza can do the job in 10 hours. So that's Eliza's individual working rate, one job in 10 hours. And I don't know Ming's individual rate, that's the question. But if they work together, it takes them 4.74 hours. So again, that's probably a truncated decimal. So we're going to get a weird answer, but that's okay. We're going to multiply these together. And then this fraction, and don't reduce it, just leave it as 4.74 over 10 equals 4.74 over x for the other fraction. And when you add each part of the job completed by each person, it completes one job. Alright, LCM on this question, I'm thinking 10x would work. That's nice multiplying, so that makes me happy. Alright, 10s would cancel, and we get 4.74x, plus, here the x's would cancel, and you get 47.4. And then don't forget the important 10x times 1, 10x. Alright, let's solve. Oh boy, now I think I need a calculator. Alright, so we have 47.4 equals, I know I should be able to do this, guys, I don't trust my math today. 5.26 x. Oops, can't write either. I'm on a roll. Good thing this is my last question. Dividing both sides by 5.26, and again, you're going to get something that looks like a weird answer, but it's just because of truncation, it's a little off. That's all. 47.4 divided by 5.26. I'm getting 9.01. So truncation caused it to be a weird 0.01 kind of an answer, but in my opinion, the true answer is probably Ming can do this job in 9 hours. So that's that, and that's actually the end of our rationals unit. So hope you enjoyed it. It's one of my favorites. Lots of factoring. Good times ahead, right? Thanks.